Okay, so I mentioned this on the board. I thought I'd go ahead and show it real quick. When we're in a nice IDE, I've opened up Android Studio here. You all will see that when you get to the SDEV 264 class, and just pick one of my projects. This is a game thing. Here's one of the screenshots from when I put it on the Play Store. The main point is this down here. I kind of modeled it on the old Game Boys. I think there's an updated version. These buttons are in a slightly different configuration on the Play Store. But kind of modeled after a game thing, kind of modeled after the old Game Boy setup, and then there's a whole bunch of games that go in it. But it had lots and lots of classes, as we can see, expanding these folders out here. A whole bunch of different classes to work with. Cancel that. So this one would be good for generating those diagrams. I have this plugin here, Simple UML CE. So if I click on the package here, and down here, add the UML diagram, create a new diagram. Whoops. Call this Rain Delay Games. Add folders recursively, yes. And so here's a whole bunch of different UML class diagrams. And notice how the computer can generate those, but it kind of takes a little more thought to kind of organize them on here. I expand one out here. Here's the general format we talked about on the board. And I did forget something. I had a feeling I would. That one might not be a good one for that. Does this have? Okay, this one will work. If we move this out of the way. If we extend this out here, you can see there's a section for the identifier, then a section with the fields, all the data that goes in it, and then the list of the methods that go in it. And I had a feeling I was forgetting something over on the board, and I did. So a minus sign means it's private. A plus sign means it's public. And the pound sign or hash key, whatever we want to call that symbol, that means it's abstract. So that's the standard diagram for how we diagram the information from our classes. UML Class Diagram, and as you saw there, it doesn't take any thought to create it. So usually we can just have the computer generate one for us, and it just takes thought to organize it nicely on a page. As you saw, this one I kind of like picked for the example because it just stacks everything up in the corner. The computer doesn't even try to organize it, and then we have to figure out what a good way to organize it is. And you can see the little arrows here. So let's go over to Raptor and build a simple one, but I wanted to show that normally we can just click generate and get all of those, and then we just have to make them look nice on the page, find a good order for them. So in your SDEV 120 class, you probably use this program Raptor. It's what we've been using for a few semesters now. It's a flowchart interpreter, so we basically just draw a flowchart. I should probably expand this out a little. Fill most of this area here. There we go. So we expand this flowchart, draw a flowchart, and kind of build from that. So if you still have that on your computer, you can make really nice looking UML diagrams in here. Because to do object-oriented Raptor, we start with the UML diagram. It's a diagram-based thing. So you'll come up to Mode and select Object-Oriented Mode, and you should have a tab that looks like this. This is the main. You probably work with that one a lot. But there's a tab called UML, and this is where we start creating classes to use object-oriented stuff in Raptor. But for us, it's just going to draw a nice one and print it on screen. That's part of your homework this week is to draw it. So if you still have Raptor, you can draw a nice one and just print to PDF and make it have something that looks really nice. So we'll click a new one. On your homework, if you're doing this, you can just go ahead and start with that. I'm going to go ahead and go in here and start with the object one because we talked about that, and just kind of get some basic things going. Every class in Python is descended from the object class, which has some of our basic things. So if we go in here, this button adds a new attribute or data field, and this button adds a new behavior, method, or function. I'm just going to go ahead and list a couple of these out. Let's see, what do we have? There was public void underscore init. I'll just put something here. I'll leave that blank. We would pass stuff into this method. Just do that and call it init. Then we need another one called, it'll return a string, call it underscore string. And that's kind of, yeah, those are two we'll work with. There's the other two on the list to talk about, but let's put a couple here to go over this quickly. You can see it draws that diagram for us really quickly. And then for us, we'll do a new one, a new class. We're just going to do a student class. I was thinking hopefully that's something everybody can kind of relate to and make sense of. We have these different arrows up here. Obviously comments, so we can add a few different things. When we want is inherits from, another important one you might want sometime, implements for interfaces, nested. We have different associations, composition or aggregation. You'll talk about those different types of relationships. Is a relationship or a has a relationship is kind of the difference between them. Those are the generic terms. Like is a relationship, it is a version of it. Has a relationship is they're connected. Or a dependency. Maybe our object depends on another object being created. So that little dashed arrow happens a lot. For this simple one, I'm just going to draw a simple inheritance. So student inherits from object. As we move it around, you can see the arrow kind of fills in nicely. And if you have more things, it fills in nicely. Then just getting started here, probably not going to go through the whole idea, but hopefully this will make sense for the diagram. Whoops. If we double click on it to get to this box, we can add a few things. So there are certain properties that a student is going to have, right? So maybe an identifier, which would be a string, student ID. So there's a private string called student ID. Like for us, that would be the C numbers. There's going to be some other things, private string first name should probably be there. Private string last name. Maybe just one more, not the whole plan here. What else can we put? Private int GPA. That'll be good for a method. And then we can add some new methods. So some that might seem fairly obvious. Let's see. Well, we had that GPA, so return an int get GPA. And maybe one to set that. public method called calculate GPA, which would obviously, if this was the full object, we'd probably have a list of all the grades so far, and then that would automatically calculate in the background. But just kind of going over the basic idea here, we set the attributes, the variables that every student would have associated with them, and then all the methods that we would need for a student object, and we can use them there. Our init is quite a bit like what's normally called a constructor. I thought there was an option for creating a constructor here, but I don't see it. Abstract final. Can't remember which one of these. Oh, it's this white one here. Delete this one. And this one, so our init in Python, our initialize method, is what normally is called a constructor. And that shows what values we're going to pass in. So like a student, we'd pass in a string called name, which, I'm typing that. The object-oriented version in Raptor is strictly typed. So I have to say what it is. Like I said, first name and last name. First name, string, last name, and then the rest of those fields and all those that we would need. Probably not passing a GPA, we'd calculate that, right? Methods to generate things and all that stuff. But you can see it generates really nice looking class diagrams, and if you have several, you can set up arrows, move them around. It looks kind of nice. Then you just come over here, File, go to Print, and print it out to a PDF. That's probably the quickest, easiest way to do that for your homework. Oh, I'll put this in the delete folder. UML test. I don't know why I just printed 6. Oh yeah, because it printed all these. Notice when I created a method, created those methods, it started flowcharts to draw those. So that's why it was printed 6 pages long. Might have to go back and do that an easier way real quick. What does that look like if I open it? Yeah, that gave all kinds of extra stuff. So let's do that the easier way. If you're on Windows, you can just come look for this thing called Snipping Tool. Which is being updated. There's also Snip and Sketch is the new one. You click New, and then the crosshairs just basically take a picture of your screen. Then you can just save that and put it in a PDF or send a picture of the UML diagram that way. But it's a quick, easy way to draw nice looking UML diagrams. UML test. I probably don't need to open that. I will anyway. Oh, it's over here in this machine. But a quick way to make nice looking UML class diagrams, or as we saw a moment ago, in fancier IDEs, you can just generate those. But most of you probably have Raptor on your machine still, so you can quickly draw one up. And if you want to test it, once you create the object or create the class, then it goes ahead and sets up the flowcharts for all the methods you used. And notice you also have a return thing here that probably didn't show up in your SDEV 120 class. There's some other new features, but an extra watch window and things like that. But for our purposes and the homework this week, you have to turn in a UML class diagram. with your things, so you can just draw that in Drafter really quick. That's probably some software you have on your machine. So now let's go over to Python and put one of these together and kind of see the syntax for doing that in Python. Okay, so now to doing this stuff in Python. Really just a quick pass on the syntax so you all can start working on applying these concepts. So here in idle, like normal, create a new file to work in. We'll actually have a couple files this time. I'm going to get the shell out of the way. It'll be a minute before we run anything. So our keyword in Python when we're creating a new class is going to be just class. And then we need the name that of our class. So like I said, we're going to create a students object, then a colon, and we'll hit enter. And when you're ready to do inheritance, just hypothetical here, maybe we have this person class that we're going to inherit a bunch of things from. When you inherit, you start off with that line. But we're just going to do one class here, and kind of at this level, we're just kind of starting with the idea of encapsulation. Our keyword is class, and then the name for that class. We're going to call it students. Actually, student. I'm going to take that S off there. We'll create a student class that encapsulates all the information we would expect to have or need in a program where for processing school stuff and things like that. We usually want to start off with that initialize method. So we're going to define a method called underscore underscore init underscore underscore. Then we'll pass in some parameters and type some stuff down here. Now, a key point is when we're creating a class, designing out an object, every one of our methods needs to have this parameter. We need to have a parameter called self, which, as the name kind of implies, refers to itself. That refers to the object we're making, the instance of the object, come runtime. And then we'll need some other things to pass in. So I'm going to pass in a parameter called first name, which our weekly notation is Pascal case, I believe. First name. Actually, I'm just going to use camel case. I will use the weekly notation when we write a program to call this. But I have a feeling I will confuse myself and have to do several takes on these videos if I don't do it the way I normally do it. And try to talk and type at the same time if it's not what I'm used to doing. That's shown up a few times. So I'm going to use camel case here. And then I'll use the weekly notation when we write a program that uses this object. So a student is going to have a first name and a last name, maybe a student ID. What else do we need? There's a lot of things we could go on and on, right? Put in an address, phone number, contact information, email. But we want to keep this example somewhat short. So I'm just going to go with these three to start with. When we create an object, when we ask for a new one, we're going to pass in a first name, a last name, and an ID for the student. Those things should seem familiar, right? The student ID would be like the C number here at Ivy Tech, and some sort of ID number that's consistent across every school, just a different form from place to place. So that passes them in, but we need to put them into actual data fields. And we talked about sort of protecting things. So, well, to begin with, all of our data fields we want to attach the word self to. to say it's particular to the object we're working with. So that's what this key parameter is. That's why we'll need it in every single method we write inside an object. And we don't pass that in as an argument. Python will automatically pass that in as the first argument every time. So make sure it's the first parameter in every single one. And then the parameters that you're going to fill with arguments at runtime. So self dot, well, we could just do first name. And if you want to, you could do it this way. It's a little sloppy though, because if we do this, it bypasses that protection concept we were talking about earlier in making things private. And I'll show this when we get to the running it example. It's not really private. Really private only comes in compiled languages, and we're in an interpreted language, so we don't really have private. But we have this thing we use, which is semi-static. It's like static, only it's static for the particular thing, but static variables and methods are definitely beyond the scope of this course. So it's semi-static, and we can still access it, but not easily. So this is typically used in Python to represent things we would want to treat like a private variable or private method is 2 underscores. And that makes it hard to access it from the outside. But when we get to the program, I'll show you how to access it. It's not really private like we would have in a compiled language like Java or C#. I'm going to create a field here called first name and assign it that first name that was passed in. And we could change those so they don't match up. They look a lot alike after you've done this for a while. Like when I'm typing this and referring to things, I ignored this entire part here. And I would just say first name. And sometimes even when reading code, after reading code for hours and hours and hours, start to not even look at that part. So in that case, it looks like they're the same, but so we could call them something different, but the computer would never get them confused. So it's very beneficial to call them by the same name. That way it makes it a little easier to keep track of what's what. And I'll do that for all of these. So self dot underscore underscore last name equals that last name variable that was passed in. And that's last name parameter that was passed in. Self dot underscore underscore student ID is going to be the same thing, the one that was passed in. And I will stop saying underscore underscore now. You'll be able to see it's on there. And all of these things with the double underscores, that I'm going to say private, but again, we only do this in Python to treat things the way we treat things as private variables. It's not really private. Then there's a couple other things we could use, we could put in here. Self dot grades. That's something we'll need. I'm going to set that up as an empty list, and that'll be one of our behaviors, is adding grades to the list of that student's grades. Sort of a condensed version of a transcript. We'll just pass in a bunch of things so we can calculate the GPA, which would be another good one to put in here. So the .GPA variable. And the double underscores there are to kind of protect everything. So that'll be a good start. Obviously, there's a lot more. You can go on and on thinking about a list of this. And just to mention it, that is part of your homework assignment this week. On one of the ones everybody was assigned, one of the two programs will ask you to add another field. For example, some people got the employee class as their assignment. So it has like 3 or 4 fields about an employee, and I just asked to add at least one more. That's worth a few points, and if you add a lot more, some good ones, that'll be some extra credit as well So think about things that you would want to include in the class that you're making. Other things that you feel like would probably be there. Like the employee class, as the book gives the assignment, is very straightforward, like a name, address, and they leave off things like vacation hours. You put a field for vacation hours and then a method that deducts vacation hours when they take a day off, or sick days, or something like that. Something that you think would be good to encapsulate in the employee object, or whichever one you get with the assignments. But that's what we'll need to initialize this. We'll pass in some things with a name and an ID, and then internally there'll be a list of grades, which is a stripped down version of a transcript, and then we'll use those grades to calculate the GPA. That's kind of a rough plan on this to go over the syntax, but make sure you include this one. Always need the initialization method. And double underscores init, double underscores the parameter self, always goes first in everything you do in objects, and then the parameters that you're going to fill come runtime. So that's what the initialization method will kind of look like. And when you're doing inheritance with the objects, you'd also put a call here, a callback, passing whatever parameters or arguments needed to the superclass or parent class. But as I said earlier, the first example I put together was way too complicated for a class that has introduction to names, so I stepped back and stripped it down and thought about what the most important part was. And the first brick in this nice solid wall of knowledge about programming we want to build is going to be encapsulation. So that's what we're going to focus on at this level. And then you have at least 3 more classes coming in the degree program where you'll learn more and more about objects as you move along. So you get into inheritance as you move forward. The book covers this pretty well, though. The chapters 10 and 11 about object-oriented things, I was very, very happy with the way our textbook presents it. Just wanted to include it in the lecture, kind of walk through and talk about it, talk about some things with it. So that's the initialization method. After that, something we'll often need is, I'm going to use the term private because that's a lot easier to say than semi-static, double underscore semi-static variable. So I'm going to say private. So we made these things private. So they're in that inner circle of that picture that I drew when talking about the concepts. So we need something in the outer circle, a public thing that can access them. So we'll set up functions to do that, behaviors. And typically we call these getters and setters. On a multiple choice quiz or something, the technical term is going to be mutators and accessors. Obviously mutate to change something, which we're going to call setters because that's the keyword we always use, or that's kind of standard for programmers to use, or accessors, which is get. Is it a keyword? And when talking about it, programmers just say getters and setters. But on multiple choice quizzes, like certification exams, the technical term will be mutators and accessors. So we need getters and setters for all of these. So I'm going to make one called get first name. We don't need to pass anything in, and we'll return that self. That first name variable, that private one, is kind of protected. And same thing, if we want to change it, set first name. And then we want to pass in something to change it to, if we're changing it. So first name will be reassigned that first name parameter that's passed in. So here's our accessors, and our mutators would be the technical terms, but when talking to other programmers, you're just going to say getters and setters. And we want to set those up for every one of our fields here so that there is a behavior to access these private things if needed. And in most IDEs, we can usually, there's an option to just generate these because they're always going to look the same and be consistent. So typically if you're working in a nice IDE, there's going to be an option just to access it. One I like to use in Python is called Spider, and yeah, then it would just generate all the getters and setters at the click of a button. That way, the computer never makes a typo, so it's a little safer for one. Also, might want to get the last name of the student and return self._ last name. Define set last name, which is one that would probably be used a little more often, right? See it happen all the time here at Ivy Tech. When women get married here at Ivy Tech, they go through, there's always a big ordeal to get their last name changed with all the Ivy Tech stuff. And a lot of them kind of give up and just like, oh, whatever, use the maiden name on the email address. So that's one you want to remember is if you're doing stuff about, no matter what, if you're using people's names, remember to make it easy to change the last name, because women do change their last name when they get married, and they want to see their new last name on that paperwork. I've seen that happen to a lot of people at Ivy Tech over the years. They kind of give up before getting their email name changed and everything. I'm guessing it happened to one person in this class too. I noticed the email name is different than what I know your husband's name is, and the name you put on your homework matches your husband's name. So that's, yeah. Just a general note for developing software. If last names are involved in your objects, make sure it's easy to change, because that's something women are going to want to see. What else do we have? Get student ID, return self _ student ID. Whoops, don't need parentheses there. Find set student ID. Well, you know what? This one we wouldn't need a setter for this one. We're going to change the student ID. That's assigned, and that sticks with you. You know, that's assigned to you, and that's one that is not going to change. So let's not even make a setter for that. So keep things like that in mind. You're not going to need a setter. And along those lines, we could probably delete this setter for first name. We don't need that. Oh, and a general note. A general rule of thumb, never do what I just did. If code works, do not delete it. Comment it out, and then after you know those changes are okay, then delete it. But just to express the point that first names and student IDs probably aren't going to be changed. So we don't even need a setter for those. The grades, well, we don't want somebody to easily go in and change the grades, so let's leave a setter for that only when we need that. I guess we could put a getter for it, though. Define get grades and return self grades, which will return that list of things. Same thing with GPA. We don't want anybody to easily be able to go in and change the GPA. We only want that one changed by calculation. So, but we might want a getter for it, so like get GPA. Return self.GPA. So there's our getters and setters, and we don't necessarily need getters and setters for everything, just the ones that we expect to get or need to be set. Now that we have this method to initialize our object, and then ways to access the data fields, attributes, or properties that we'll need, we can start working on just some the methods that we'll need, the behaviors that we want from this object. Which, to keep this example somewhat short, well, right off the bat, I'm going to come down here and put in these scroll things out. I always do white space for scrolling. And I always put that in because I don't like to work at the top or bottom of a window. I like to try to work in the middle. So notice how the cursor, when I click, is going to the wrong spot. I always just let the computer reset that, so I'll come back up to the previous line and hit enter a couple times. That way it has the right indent. So the first method we want is to probably add something to this list of grades. Define add grade, which is really just going to be a modified append to a list. That's all we need to do. So we're going to pass in something called grade, because obviously we'll add a grade and then we'll pass in whatever that grade is going to be. And well, then we can just append it to that list. So self._grades .append, and we're going to add that grade that's passed into the list. And then we'll just fill up that list of grades the students had that way. You see, really, it's basically doing the same thing as the append method. We just put a better name for it for our particular object. And we probably want something to calculate the GPA now, and that'll be good for this. The idea is encapsulation. The stuff we need is all included in this object, so that when we go to write a program that needs, or a program that does stuff with students, we have a student object that has all the things we'll need already included and ready to go for us. So obviously there's a little bit of pre-thinking about what needs to go there, and figure out what you need, and that way you're not constantly coming back and adding stuff, and try to get it all set up to begin with. Although updating is not out of the question, right? If we come up with another need later, we can always come back and add it in. And I haven't saved, so I should probably do that. So Control S to save before we get too far in. It's always a good idea to do that. On the USB drive, this is Module 5 Lecture 1, our example files, and I'm going to call this student. It's also a good form to put each one of your objects in its own file if you can. It helps with organization. It used to be an ordeal with disk drives, because there was the time taken to find it had to be considered. So we'd want a lot of stuff in the same file, but as everything moves to solid state drives, more and more technology seems to be moving that way. Solid state drives do better with lots of small files, because then it doesn't have that look for it time, it just grabs it. And it kind of helps with organization, keeps the files smaller. But either way it works. We can build a whole module with a whole bunch of objects in it and just bring that in. But it can be a good idea to do one object per file. So we'll get into grades, and we need a way to calculate this GPA object. Calculate GPA. And all we need to calculate the GPA is the grades, right? We'll add everything up. It's a weighted average. So we'll add the add the grades up with their weights, and then divide that by the number of credit hours taken. We should probably do a credit hours list as well. So revamping this, I'm going to add a list for credit hours. And I will just fill that up with this same method. When we add a grade, we'll say like a B, and we'll also pass in the credit hours. So like a B in an English class, we pass in B3 for hours. And then that way, they should stay in the same, line up in the same spots. There's better ways to do that, but I want to keep the example somewhat short here. So for hours, and then we'll append on the hours passed in. So then for like this class, I think it's a 3 credit hour class. It might be 4 credit hours, but 3 credit hours, pass in an A for the grade and a 3 for the credit hours for the class. And we'll need those to calculate the GPA. So now down here in this method, well, we need the number of credit hours taken, and we can just loop through there and do that in a for loop. So for H in hours, I guess we need a sum thing to hours taken. We'll start at 0. Hours taken increments by whatever the next thing in that list is, and that'll give us the number of credit hours taken. Or when we do our weighted average, then we divide by that. Hopefully all this makes sense. If you haven't seen how we do the credit hours, so like if there's a B, it's worth 3 points multiplied by the number of credit hours, so like a B in a 4 credit hour class, plus a C is worth 2 points times a 3 credit hour class. And we add all those up and divide by the credit hours. Sort of a weighted average if you haven't seen that before. This example is about syntax, so hopefully you're somewhat familiar with taking weighted averages. Saw that in a math class or something. And hopefully the logic for this kind of makes sense, or is something we've seen before as we go through here. Now we need to find out the point value for the grades. So for that, we'll walk through each one. So for G in grades, how I want to do this? I'm going to pause the video and make sure I do this right. So what I was getting ready to do, we haven't seen here. So I paused the video and thought for a few minutes and realized that a while loop will be better here because we have seen how to do those. So we'll start it at 0. And while the counter is less than the length of either one of those, so self dot grades. They should have the same number in them, so the length of either one, we'll just walk through until we get through there, through the list of grades. Then I'm going to create this variable called weight that will the weighting for our averages. We'll start it at 0. So each time through, that weighted variable is going to increment by what's in self grades, whatever counter index we're on, times self hours, the counter we're on. So we'll look at the same index each time. So like 0, the grade 0, and hours 0, multiply those together and add that to the weight. So if it's like a B, that'll need to be a 2. And if it's a 3 credit hour class, it'd be 2 times 3. But grades are a letter. So we need to set up a method to turn this into the actual value. So instead of grades, we want the value for it, which you've probably seen this as, it's a common example. We'll do it as an if block. So if self grade whatever one we're on is equal to a letter A, then we want something called score. That'll work. Score equals 4. So we get 4 points for an A. And then we want to do all those. And to avoid typing that a bunch of times, I'm going to copy that. Control copy, paste that, only now it's an elif, else if. It's a B. We'll give, that'll be 3 points. Control paste. I guess I could have copied that one that had the elif on it. A C is worth 2 points. Whoops. Paste that back at this indent level. What's next? A D is worth 1 point. Anything else isn't worth any points. So we're going to take whatever that score for their grade is, which is just a local variable here, so it's not something we could really even access from the outside. Notice how there's no self on it. Oh, and I left that out. That's going to be a problem. I was talking while I did this, and earlier today I was typing another programming language and I forgot to do that. I mentioned it earlier. Every single one of these needs to have self passed in as the first parameter. And then the computer will pass that argument in. The particular instance of the object we're working with will be passed in as the first parameter every time. Sorry about that. That completely slipped my mind when we got to the getters and setters. So make sure you type that self thing every time. Oh, need it here as well. Self. So that refers to the instance of the object. So now we're back here. So we'll get the score for whatever the grade is. Then we'll multiply the score by the credit hours to get how much that particular course grade is weighted when calculating the GPA. I'm kind of just assuming here that you've seen weighted averages in one of your math classes. If you haven't seen weighted averages, let me know. Oh, I just noticed a typo. We'll fix that here in just a second. If you haven't seen weighted averages, let me know, and I'll go over it. The general idea, I assume everybody's familiar with averages, where we add everything up and divide by how many we have. But oftentimes, the things we have some are more important than others. They aren't all worth the same amount, and that's what the weighting is. For example, like with the GPA, your 1 credit hour welcome to college course that everybody has to take is not as important when calculating your overall performance as, say, a 4 credit hour chemistry class. Right? That really hard chemistry class is worth more in evaluating your performance than the 1 credit hour welcome to college, here are some study tips class. So the weighting is like the importance level of it, how important that particular class is instead of just a straight average. If you haven't seen those in math class, let me know. And while I was circling the mouse around, I noticed a typo right here in the for loop. We don't want to walk through hours. There's not even a variable called hours. There's a private list called self.__hours, and that's what we should be walking through here. Self.__hours. Sorry about that. I carried away and forgot the first part that refers to the private hours list in the object we're working in. So back to this now. Finishing this up, that gets kind of the importance level of all the scores calculated into the average. So then we can increment our counter to go through the loop, which will finish out the loop, and afterwards we can set that GPA field to that weighted sum and divide by the hours taken to get the actual GPA. Now we need to call this, but this is kind of an internal thing. We don't necessarily need the user calling this every time. We want this to happen automatically. So maybe when we add a grade, that'd be a good time to call calculate GPA. So if we want to call that, well, the same way we referred to our data fields up here, we had to say in the object we're working in with this keyword self. So we want to say that. So self to represent in the object we're working in dot calculate GPA. And we don't have to pass anything in. But we do have to express that it is in this method inside of this object we're working in. So that'll be kind of a quick, good example. That'll be good enough for the example on the syntax. Just some basic behaviors, some properties about a student object, and a couple behaviors we would want from that student object. So hopefully that kind of makes sense. And every time we add a grade, it'll automatically recalculate this GPA thing, this GPA field, and fill that in. So that creates our object, gives us a bunch of getters and setters so that we can access these, I'll call it private fields, and a couple behaviors that we would want from it. So the next part is going to be putting this into a program, using this in a program somewhere. Should be a very stripped down example of this, but I guess we can jump into that. So running this and looking for typos. I already noticed a couple. I'm talking and typing at the same time, and typos tend to creep in when we're just typing, so hopefully there's not too many big ones, but it might be good to see errors and how to deal with them. Now that we've encapsulated the information we want about a student object here. And just a little tip, I don't have the shell open anymore, but if the shell was still open and I hit File and New, it would go to that default save location where all the Python language files are. But here, this one's already saved. Push Control S, make sure it saves the latest version. So if I go to File and create a new file here, it'll try to default to saving it in the same spot as that one, because it goes to where the previous one was. So I guess the first thing is just a note about using it. So I'm going to create an object here called SDEV, create an instance of our class. That's where we use the term object. So we create a SDEV, and when we initialize it, we need to pass in a first name, a last name, and an ID. So I'm going to call Steve. So Steve is a student, and need a name. Steve, I don't know, Smith, good common American name. And the student ID, we'll just say he's student number 34. Obviously, student IDs are usually a little more intricate than that, but for our example, that'll work. So I'm going to save this. And yeah, this is the little thing. Since I opened it from here that was already saved, it tried to default to the same thing. That can be a bit of a time saver. Testing student class. So let's run this and address a point that we've already seen. Hit F5. Oh, student is not defined. It has no idea what student is. And this is one we've seen before. It's in a different file, so we need to import that. So import student. And what we've seen, like we've seen before, if we import the module, well, we need to use the dot operator. So student.student. So S, run that. Uh-oh. Student object has no attribute student GPA. So I'm going to pause the video, figure out where that typo is, and be right back. Okay, sorry about that. That was another one that came from, I was typing in another programming language earlier today. Probably should have typed something up in Python before getting back to making the videos. I was in Java where we do not have to assign default values. We can just leave them blank when we initialize the object and fill them in later. But in Python, we do have to have something there. So GPA has to have something there. So I'm going to start with a 0 because that'll be a number. But we do need self.gpa to equal something. That's why it says has no object. And notice what it called. That's how we can ask for that. So now if we come over here to test student, look for more imports, more lines. We run that, it kind of came through everywhere. So we can do like steve.get name. And that should return our name. Whoop. I don't know what just happened there. Sorry, that was kind of a dumb moment. We don't have a get name. We have a get first name or get last name. Steve.get first name. Yeah, there we go. So return that. I'm going to clear this out. And before we run that again, I'm going to comment this out and just copy this line. Control copy, comment that one out, and then paste it. Whoops. And then paste a new one in here. Because this is one of the places, notice that student.student, a little bit redundant. So this is one of those places I like to use that other import notation. So from student, import everything. So import everything from this other file over here. So Steve, and then we don't need the dot operator to call it. Especially if we're writing our own objects, I find that a whole lot easier to work with. If we import it this way, we don't need the dot operator to call it. So if we run that, hit F5 to run that, then we have that Steve object, so we can call some of the methods. So Steve.get first name, Steve.get last name, Steve.get student ID. Oh, must have got a typo there. Has no object get student ID. Oh, has a lowercase d in it. Steve.get student ID. There we go. Return the ID. a typo somewhere in there. I think I meant to have a capital D here. But that couple of those getters work. We have this setter for the last name, but I'll use that to show how we can access those. Remember, we said we were treating that it was private, but it's actually something different. So what we could do, we have this access in Python if we do underscore, then the class name, then the double underscore, last name. If we type in all of this, underscore, class name, double underscore, attribute, we have access to it. So equals, maybe that was supposed to be Steve Jones instead of Steve Smith. So then if we do Steve.get last name, Steve.get last name as a method, we get that name we changed it to. Typically, we don't do this. Since there's not private data fields in Python, it's kind of understood between programmers that if somebody uses the double underscore, treat it like it's private. But it is accessible. But when working in Python, it's customary to go ahead and act like that is private and not access those in that manner. And let's see, so this notation I think is a whole lot easier to work with when we have objects. So why don't we run that and again and test some of our other methods. So run that. So we should have the Steve object in there. And well, we need to test these behaviors we put in here. Right now the GPA is defaulting to 0. So let's add some grades to our Steve object. So like Steve.add grade, and let's see, maybe Steve got a B in a 3 credit hour course. Steve.add grade, maybe got an A in one of those 1 credit hour welcome to college courses. Steve.add grade, C in a 3 credit hour course. Steve.add grade. Let's say an A in some really hard science, 4 credit hour science course. So that should have filled out a list of grades and credit hours so that we can, and every time through, it should have calculated the GPA internally. So now we should be able to go Steve.get GPA, and it returns his grade point average from all of this, which is pretty close to a 3, which a 3 is a B something. So this A brought it up, but this C brought it down a whole lot, but this A wasn't as important, so it didn't help bring it back up any, which left him closer to a B overall than an A, even though he got 2 A's. One of them wasn't as important. And that's how weighted averages work. If you haven't seen those, let me know. We can go over it. Hopefully the logic there made sense for those behaviors. Just kind of a quick example on the syntax, and the general idea is encapsulation. Encapsulate all the properties and behaviors you want to have in your object so that you can use it in another one. And then it's reusable, so we could create a new object, another one. Sally is another student object. We already imported that with the from notation, so we don't need to say student.student and pass in some names. So Sally Smith, she's student number 76. For student ID. Okay, so there's one more thing to do, because if we wanted to just print out the Sally object, by default it tells us what it is, student.student object at this weird looking thing. the memory location where that's at. We've talked about those a few times. But what if we tried to cast that to a string? It's giving us the same thing. That's probably not the default string we want to have to describe our Sally object. So let's look at that other method we talked about, overriding the string method that everything has. And as we look at this, putting the default one in there, I'd like to mention in the more complicated example, I have worked through both ways. I'm just going to kind of mention it without all the examples, but if time allows while you're working through this, it makes a big difference in inheritance. So you might want to try it both ways. But we want to set up a method to return sort of a default version of a string. So every object in Python, every class in Python is descended from that object class, so it inherits this method that we can use, which is the default toString thing, cast to a string basically. And we're going to return a string that represents our object. So I'm going to start typing it in with the data fields. So let's say return the string student number plus self student ID plus is named plus let's see, I'll go to the next line, plus self first name plus a space plus self last name. And we could kind of continue on to put these directly in here. The slight problem with this occurs with inheritance, because the child classes of a student object that we might potentially make in the future in different settings will inherit the stuff from here. And if it inherits the string method from this will refer to the data field in the parent class, not the one in the child class. So it's better form to use these getters and setters, because then when the child class inherits this, it will use the child's getters and setter methods, which will refer to the child's data fields, not the parent's data fields. I hope all that made sense, but the short version is it's better to use the getters and setters even inside our own object. It's just better form to use those. So we have getters for all of them, so we can put that here. So in self.get student ID, that one I kind of misspelled earlier. I think I meant to put a capital ID on there. So instead of referring directly to that data field, use the getters and setters here, because then the subclasses will inherit the string method, and when this runs in a subclass, it will refer to the subclass's getStudentID method, whereas this would still refer to the parent class, the superclass's data field. Just a subtle one, but in short, it's better to use the getters here. So self.get first name, then self.get last name. So student number, making one up here, 25 is named Bob space Jones. I'll go to the next line, plus, and has a GPA of plus self.getGPA. So we're going to return this long string to represent our objects. And it's kind of the default one. So I'll come over here and go ahead and set up that Sally object. Sally equals, well, we use the from notation. If you use this one, remember you have to use the dot operator, so you'd have student.student in this case. But with the from notation, you can just, it's already in there. So we can say student. Sally is going to be a student named Sally. Oh, I'll just use the regular name, Smith. Maybe it's Steve's little sister or something. Student ID number 75. So Control S, then F5. And if we just ask for that Sally object, this is like asking for it like we would use in a calculation. That's probably the wrong term there, but use it for it. It tells us where it's located at in memory. If we'll cast it to a string now, like we would do in a print method, or the next lecture gets into graphical user interfaces. So if we cast it as a string to fill up on the interface somewhere, oh, I forgot that same thing again. I was typing in the language. We didn't have to do that earlier today, and I probably should have practiced some Python before jumping right into the videos. But we need every time we write a method in Python, we have to make sure and pass in the self. So like in this case, that object, the instance of the student class called Sally, is going to pass in that itself. Notice the error. Takes 0 positional arguments, but 1 was given. So we told it, don't expect any parameters. And Python automatically passed in that self parameter for us, self argument for us. So 1 was given, but we told it not to take any, so remember that has to go in every single method. We'll close that and run that again. So like we just saw, if we say Sally, here's where it's at, and you might notice that I think it's in a different memory location now. There's lots of spots in RAM where that could be stored. If we cast it as a string, whoops, I forgot the things we've seen many times. And if you working in more than one language at a time, you saw how many times I've made those mistakes. We don't have to do that in Java, but definitely have to in Python. So let's see, student ID, I think that's an integer, so we need to cast that one. We don't have to do the casting in Java, but do in Python. So if you're working in one language, for a couple hours, then jump to another language, do a practice file in between. Don't be like, oh, I'm in a hurry to get this done. First name's a string, last name's a string, GPA is an integer, so we need to cast those. Because that can make a big difference. Those subtle differences are easy to forget. Where's the one I want to run? This one, F5. All right, third time's a charm, or I guess this is fourth or fifth time. So there's where Sally's at. If we cast that to a string, there we go. So there's our default output for the Sally object. So you want to make sure and put that in every time. I guess we need to give her some grades, right? Sally.add grade. We got an A in a hard class. Sally.add grade. An A, whatever other classes. Sally.add grade. And maybe she just completely slacked off in that welcome to college class. Whoops. I thought I had that one key fixed, but it's still doing that. So now if we cast that to a string, so you can see calculator GPA, but some sort of default output. You always want to make sure and put a default output for your objects. So I guess that covers most of the syntax. Sorry about the little errors there. Maybe that last one was probably good to see a couple of those, see the error messages, and I'll kind of try to figure out what they're meaning, like when that was left off. That's very cryptic, so maybe it was good to see that somewhere. But the general idea of the syntax, make sure you pass that self parameter in every single time you make a method in an object. You always want to initialize it and set up some sort of default output for it. And the general point at this level is make sure you kind of understand encapsulation. Include everything we would need from this student object to be used in a program. So mostly a syntax example here. You could probably think of a whole lot of other things we would want in an object, a digital version of a student, right? Still a whole lot of things to go, addresses, classes, a list of the classes they've taken, not just the grades, and emails, phone numbers, all sorts of things that could still go in there. But the idea is include everything you need, and then the rest of this is just some syntax. And remember, you always want to do these: a default output and what's needed for initializing it. And in Python, every variable needs some value. When we initialize it, make sure everything is set to something. Then just import it, and you can see here we use the dot operator to call any of our things. So that's kind of the gist of this. These videos have already ran really, really long. The book covers a lot of that as well. Encapsulation is kind of the main starting point to get out on. And you have more classes going over object-oriented stuff, so just kind of introducing it. And then you'll work with it over and over again, get more and more used to it. It's a little bit different. Well, you've already worked with it. We've already used object-oriented stuff, right? We've used the dot operator a few places already. That's because those are objects built into Python. Now we're starting to build our own objects. And like everything else in programming, that just takes some practice. So that's kind of the syntax for it. And I'll let you run with that and get some practice. And next up is graphic user interfaces. So our outputs will look a whole lot better than this, just in text and event-driven programming. So we don't just start at the beginning and go to the end. Our program reacts to what the user wants to happen, right? Mouse clicks, key presses. So that's the next lecture, but go ahead and get started practicing with the object-oriented stuff. So that was a quick pass on the syntax. Hopefully all that made sense. And I'll see you in the next video.